So you've watched the video lesson on using domain restricted functions, and now we want to start applying that to graphing piecewise defined functions. We're going to graph each piece of the function, each separate equation of the function using its domain restrictions. We're going to use those domain restrictions, just like we did in the last video lesson, to find the endpoints. So again, we have a function with three pieces. Now a piecewise defined function could have only two pieces. It could have more than three pieces. I like using three because it's not too many, but it gives you a lot of practice with the idea of different domain restrictions. So we're going to find the endpoints. We're going to use the domain restrictions to find the endpoints. And then we're going to decide if we need an open or closed circle. So let's start with the first piece. I like to label what I'm doing because that way I can keep track of all of the different equations I'm writing. So for the first piece, I see that I have a 0 for my X restriction, my domain restriction. That means I'm going to find the f of 0. I'm using this. That's not what I meant to do. I'm using this equation. So we're going to substitute in 0 and see that it equals 0. So when X is 0, Y is 0, or the f of X is 0, do I need an open or closed circle? When I look at the symbol, I see that it is a less than symbol. There's no equals. That means I'm going to use an open circle. Let's look at the second piece of this function. Again, we have 0. This means we're going to find the f of 0, and we're going to use this equation. We see there's no x in that equation. The f of 0 simply equals 2. When x is 0, y, or the f of 0, equals 2. Will we use an open or closed circle? Well, we can see this is an equal sign. That means that we're going to use a closed circle on this point. Let's look at the third piece. Again, we have a 0 here, and we're going to use the equation for this piece. So we're finding the f of 0, and we're using the equation 0 plus 3. We see that this equals 3. When x is 0, the f of 0 is 3. Will we use an open or a closed circle? Well, this is not equals, so we're going to use an open circle. We have 3 endpoints. 2 of them have open circles. 1 of them has a closed circle. Here's a second example. Let's work through this one. We're going to start with the first piece. We see that this one has 2 values of x in the restriction. That means we need to find the f of -3 and the f of 1. We're using both of those endpoints. we're going to use this equation for each of them. So we have -2 times -3 plus 1. And we have -2 times 1 plus 1. So I have two ordered pairs. When x is -3, y is 7. When x is 1, y is -1. We need to decide if they need open or closed circles. I see for -3, we have an equals. This one's going to have a closed circle. We see for 1, there's no equals. It's going to have an open circle. Why don't you find the ordered pairs that will be our endpoints for the second piece? Decide if they're going to need open or closed circles. Again, we had two x values for our domain restrictions here. I needed to find the f of 1. It was equal to -3. And I needed to find the f of 2. It was also equal to -3. So when x was 1, y is -3. When x is 2, y is -3. Both of them require a closed circle because I see that x could be greater than or equal to 1. X could be less than or equal to 2. We needed closed circles. Pause your video and find the endpoint for part 3 and whether or not it will have an open or closed circle. So we used x equals 2 and found the f of 2. We used the equation x squared. This gave us an endpoint at 2, 4 with an, oh, I put a closed circle there and it should be an open circle because x is greater than, not equal. Go through these examples again so that in the next lesson we can put all of this together and start graphing our piecewise defined functions.